Let's do this one last problem, and as we do, we look at this and try to figure out how we can decompose this. Well, first of all, you might notice that the denominator does factor. It's x minus 4, x plus 2. That's fine. That's going to come in handy later, but if you look back at the very beginning of your notes, there are some hints, and there are some procedural hints that you can follow. And one of them says this. Let me find the exact thing. It says something that I can't find. Here we go. Divide if the rational function is improper, meaning the degree of the numerator is larger than the degree of the denominator. We can't use partial fractions on this problem until we divide. So let's divide. Let me state the obvious. Synthetic division is definitely out for multiple reasons, but trinomial, it's quadratic, it's all kinds of reasons. Okay, so we're going to use long division. X squared minus 2x minus 8 goes into 2x cubed minus 4x squared minus 15x. I almost said plus 5. And we'll just go through this very quickly. This process won't take long. X squared goes into 2x cubed this many times. Whoops, just x, not x squared times. Goes in x times. Basically, we're dividing this by this. X times x squared is 2x squared. Oops, 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 oops. I have messed up already. There we go. Now I fixed it. Sorry about that. Yeah, overlooked something. Clearly overlooked it. Sorry. X squared goes into 2x cubed 2 times with another x as well. So 2x times this is 2x cubed. 2x times this is 4x squared. 2x times negative 8 is negative 16x. And we will subtract. If it helps, you can say, oh, let's just change the signs and add. So when we do, these cancel. Man, this is convenient. We have 1x, we'll bring down to 5. X squared does not go into x plus 5. All right, cool. So here's what we're really integrating. We're integrating 2x, and we're also integrating x plus 5 over all that stuff right there. So x plus 5 over all that stuff right there. And then dx, we'll put the parentheses here. So we did a little bit of long division just to really get it set up. This requires partial fractions. Okay, again, at the very beginning of the notes, there are these directions, and they say divide if necessary. If it's improper, no longer is this improper. This is proper. The degree of the numerator is less than the degree of the denominator, so it's a proper fraction. So let's continue. Okay, I'm going to jump straight to the final answer on one part. If we integrate 2x, we're going to have, my final answer is going to go down here. I'm going to have x squared. All right, so blah, 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 blah. There's that. This is the one that's going to give us the most trouble. So we're going to kind of hold our thoughts. No, plus c. I haven't forgotten my c. So what we're going to do is use partial fraction decomposition on this one. So x minus 4, x plus 2. Let's go quickly. We've been through this process several times already. This is a over x minus 4. Handwriting's getting sloppy. b over x plus 2. So x plus 5 equals a times what I need for this fraction, so x plus 2, and then b, what I need for this fraction, x minus 4, and we'll pick a couple x's. X could be, let's say, negative 2. That will cancel out this term. Negative 2 goes here, that gives me 3. Negative 2 goes here, that gives me negative 6b. Am I right? Yeah, okay. So b is negative 1/2. All right, cool, that works. And then let's suppose x was positive 4. This term is gone. So 4 plus 5, so 9. And 4 plus 2, so 6a. So a is 3/2. Okay, so as we continue with this problem, I'm going to erase this problem. As we continue with this problem, we're going to be dealing mostly with that. We know how to integrate 2x, but this is the one that's going to give us the trouble, but we have what we need with it. So I don't want to lose track of this as we go through it, because we get into these really difficult things and we're dealing with this and going through some old algebra, and we kind of forget we had this term, and then we get to the final answer and we leave off an x squared. That would be tragic. So I'm going to carry that with us as we go. I don't want us to lose sight of that. So if you did what I did and you went ahead and wrote the answer and what you knew, that's cool, but I'm going to run out of room, so I erased it. So let's keep going. This is really the integral of 2x dx. Put the 2 in the front if you want to, not a big deal. And this is, oh my goodness, I erased it and I needed it. It's okay, I have it on paper somewhere. The integral of a over x minus 4. Looking, where did I put it? Here it is. I think I worked it out first. There we go. Thank you, mate. I'm glad I wrote that down earlier. I knew the numbers, I just didn't know which one went with what. Okay, now we'll just integrate. And so when we integrate, we're going to get our final answer. This is not going to be that bad. Derivative, antiderivative, integral. 2x is x squared. Integral this is 3 halves. ln x minus 4. And, whoops, negative 1/2 ln x plus 2. And we have a c. Are we finished? Yeah, we are. And if you wanted to factor something out here, like you could factor out a 1/2 and leave a 3. I'd choose not to. It's good. We can leave it like that. There we go.